The mysterious interstellar object, known as 3I/Atlas, has ignited intense global curiosity, scientific debate, and public speculation. While some voices have suggested extraordinary explanations, even hinting at alien technology, respected theoretical physicist Michio Kaku offers a far more grounded interpretation. According to Kaku, the unusual characteristics of this object are best explained not by extraterrestrial engineering, but by something far more profound and scientifically plausible: extreme age. The discussion gained renewed attention after Kaku appeared on NewsNation Prime, where he addressed claims made by Harvard astrophysicist Avi Loeb. Loeb has become widely known for his willingness to explore unconventional hypotheses surrounding interstellar objects, including the idea that some may be artificial in origin. His observations of 3I/Atlas, particularly its lack of a traditional comet tail and its unexpected chemical signatures, have fueled speculation far beyond the scientific community. However, Kaku urges caution. To understand why 3I/Atlas appears so unusual, one must first understand how astronomers typically classify comets. Most comets observed within our solar system are believed to be between 3 and 4 billion years old, remnants of the early formation of the Sun and planets. Their composition, behavior near the Sun, and characteristic glowing tails are well documented. 3I/Atlas, by contrast, does not neatly fit into this familiar category. Kaku suggests that this object may be as old as 7 billion years, making it significantly older than our solar system itself. If true, this would mean the object formed around an entirely different star system, long before Earth even existed. Over such an immense span of time, an object traveling through interstellar space would encounter countless environments: nebulae, stellar winds, radiation fields, and molecular clouds, each contributing subtly to its evolving composition. This is not an ordinary comet, Kaku explains, but that does not mean it is artificial. One of the most frequently cited anomalies is the detection of nickel emissions. Nickel is not typically associated with comets in large quantities, leading some to question whether the object composition could be engineered. Kaku counters this by emphasizing time as the key variable. Over billions of years, an object drifting through the galaxy would naturally accumulate unusual elements and gases, altering its chemical fingerprint far beyond what astronomers expect from younger solar system comets. In this context, nickel is not evidence of technology, it is evidence of history. Another major point of contention is the object's apparent lack of a visible tail. Traditional comets develop tails when solar radiation heats their icy surfaces, causing gases and dust to stream outward. However, not all comets behave identically. Age, surface composition, and exposure to radiation can significantly alter how volatile materials respond to solar heat. If 3I/Atlas has already lost much of its volatile material over billions of years, its muted response to the Sun becomes far less mysterious. The most provocative claim, however, centers on the object's change in velocity as it passed near the Sun. Lobe has suggested that this acceleration could be consistent with propulsion, a claim that captured headlines worldwide. Kaku strongly disagrees. While acknowledging that the observed increase in speed is unusual, Kaku stresses that natural explanations remain far more likely. One possibility is outgassing, the release of material from beneath the surface that produces thrust without forming a visible tail. Another possibility is structural fragmentation, in which a small piece breaking away alters the object's momentum. These effects are not smoking guns, Kaku states. They happen in nature. Importantly, Kaku does not dismiss speculation outright. He recognizes that questioning assumptions is a vital part of scientific progress. However, he draws a clear line between curiosity and certainty. Speculation, he argues, must be quantified. What is the probability? Kaku asks, is it 1%? 1/10 of 1%? Without that context, speculation can easily turn into public panic. This distinction is critical in an era where scientific headlines spread instantly and often without nuance. The suggestion that an interstellar object could be an alien probe captures imagination, but without measured probabilities, such claims risk misleading the public. Meanwhile, NASA has stated clearly that 3I/Atlas poses no threat to Earth. The agency reportedly captured high-resolution images of the object on October 2nd, and the comet is expected to make its closest approach to Earth around December 19th before exiting the solar system permanently. Kaku agrees with Loeb on at least one key point: transparency. Both scientists believe NASA should release its latest data to the broader scientific community. Open analysis, peer review, and collaborative interpretation are essential, especially when dealing with rare interstellar visitors. The more eyes that examine the data, the clearer the picture becomes. But Kaku remains firm in his conclusion. There is no compelling evidence that 3I/Atlas is anything other than a natural interstellar object, albeit an extraordinarily old and scientifically valuable one. In many ways, Kaku argues the true wonder of 3I/Atlas lies not in science fiction, but in cosmic history. This object may be a traveler from a time before our sun ignited, carrying within it chemical records of environments humanity has never seen. Studying it could offer insights into galactic evolution, star formation, and the processes that shape planetary systems across billions of years. Rather than asking whether the object is artificial, Kaku suggests a more meaningful question. What can it teach us about the universe before we existed? As 3I/Atlas continues its silent journey through space, it serves as a reminder that the cosmos is far stranger and far older than human intuition often allows. Extraordinary claims may capture attention, but careful science, patience, and evidence remain our most reliable guides. In the end, the story of 3I/Atlas is not one of alien engines or hidden technology. It is the story of time itself, written in rock, gas, and motion, passing briefly through our solar neighborhood before disappearing back into the vast darkness from which it came. And that, according to Michio Kaku, is more than extraordinary enough.